Today we will talk about conics. First, let us define a cone. A cone is formed by rotating one of two distinct non-perpendicular intersecting lines about the other. The point of intersection is the vertex of the cone. Any position of the rotating line is an element of the cone. The intersection of any plane with a cone is called a conic section. These are the conic sections: the circle, the ellipse, the parabola, and the hyperbola. Now let's go to the first conic section, which is the circle. A circle is the set of all points in a plane that are at a constant distance, the radius, from a fixed point in that plane. The fixed point is the center of the circle. We have two formulas in finding the equation of a circle. First is for the circle which has its center in the origin, and the second is for the circle which has a center that's not in the origin. So we have Theorem 1.1. It states that the equation in standard form of a circle centered at the origin of the radius r is x squared plus y squared equals r squared. We must prove that the point xy is on the circle centered at the origin with radius r if and only if x squared plus y squared equals r squared. Assume that point xy is on the circle. Then it is a distance r from point 0, 0. By this distance formula, which is d equals the square root of quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared, we get the distance. So substituting, we have r equals the square root of quantity x minus 0 squared plus quantity y minus 0 squared. And simplifying, we have r squared equals x squared plus y squared. We have now shown that if point xy is on the circle, then x squared plus y squared equals r squared. Now assume x squared plus y squared equals r squared is true for a point xy. This can be expressed as quantity x minus 0 squared plus quantity y minus 0 squared equals r squared. Finding the principal square root, we have the square root of quantity x minus 0 squared plus quantity y minus 0 squared equals r. Thus, the distance from point xy to point 0, 0 is r. So point xy is on the circle. We have shown that if x squared plus y squared equals r squared, then point xy is on the circle. Thus, the two parts of the proof together show that the equation x squared plus y squared equals r squared gives all the points of the circle and no others. Let's see example number 1. Find an equation of a circle with center at point 0, 0 and radius square root of 5. First is we know that the standard form for a circle centered at the origin is x squared plus y squared equals r squared. Then substituting square root of 5 for r, we will have x squared plus y squared equals the square root of 5 squared. And simplifying it, the equation of the circle will be x squared plus y squared equals 5. Next is Theorem 1.2. It states that the equation in standard form of a circle with center point hk and radius r is quantity x minus h squared plus quantity y minus k squared equals r squared. Let's solve example number 2. Find an equation of a circle with center at point -1, 3 and radius square root of 2. Substituting the given point and radius to the standard form of the equation, we will get quantity x minus -1 squared plus quantity y minus 3 squared equals the square root of 2 squared, and simplifying it, we will have quantity x plus 1 squared plus quantity y minus 3 squared equals 2. Now try this. Find an equation of a circle with center and radius as given. Center is point 0, 0 and radius is square root of 6. Center is 0.5, -2 and radius is square root of 3. Center is point -37 and radius is 5. Center is point -2, -6 and radius is 2 square root of 7. Next is finding the center and radius. We have example number 3. Find the center and radius of x minus 2 squared plus y plus 3 squared equals 16. We first write the standard form x minus 2 squared plus y minus -3 squared equals 14. The center is point 2, -3 and the radius is 4. Now try this. Find the center and radius of x plus 1 squared plus y minus 3 squared equals 9. Then graph the circle. Next topic is finding the standard form by completing the square. Completing the squares allow us to find the standard form for the equation of a circle. We have example number 4. Find the center and radius of x squared plus y squared plus 8x minus 2y plus 15 equals 0. We complete the squares to obtain standard form. Quantity x squared plus 8x plus quantity y squared minus 2y equals -15. We add 16 to both sides of the equation, so quantity x squared plus 8x plus 16 plus quantity y squared minus 2y equals -15 plus 16. Then we add 1 to both sides for completing the squares, so x squared plus 8x plus 16 plus y squared minus 2y plus 1 equals -15 plus 16 plus 1. Simplifying the equation, we will get x plus 4 squared plus y minus 1 squared equals 2. In standard form, the equation x minus -4 squared plus y minus 1 squared equals the square root of 2 squared. The center is point -41 and the radius is square root of 2. Now try this. Find the center and radius of the circle x squared plus y squared minus 14x plus 4y minus 11 equals 0. Find the center and radius of the circle x squared plus y squared minus 12x minus 8y plus 27 equals 0. That is all about the first conic section, the circle. Thank you.